Okay. It's coming up to my 5 minutes. Like everyone else, I hope you guys had time to take a quick refresher. We're going to jump into something a bit more technical now. We're going to be looking at hashing, nodes, and mining. Hashing, nodes, and mining. Some words that you might know, some words that you might use as a Bitcoiner, but if you're new to Bitcoin, these might be totally new concepts, but we're going to delve in. Okay. Special shout out whilst people come and find their places again to CoinCards, who's our stage sponsor. They're the people on which put me this stage, and I'm happy to be here sharing these workshops with you guys. So shout out to CoinCard for being our sponsors. And shout out to Ian as well for the coffee whilst we're giving a shout out to some people. Okay, let's jump into workshop number 2. How's everybody feeling on a thumbs up, thumbs down? Like, thumbs up is top, thumbs in the middle, okay. All right, we got a lot of thumbs up. Good. Always good to take a check, see how you're feeling. So the objective of this workshop is to understand the cryptographical basics of Bitcoin and blockchain. Now, before I start this, you don't have to be an expert in any of this to use Bitcoin. You really don't. Hashing, nodes, and mining are things you never have to master to use Bitcoin successfully. However, people always come up with questions. And like I said in my introduction, sometimes the simple question requires a technical answer. And it's in that technical answer that you can get lost. So hopefully we can take some time today to try and piece together what hashing is and how Bitcoin runs and how it works. I think we got all of our materials divvied out as well, but if you can just do a bit of table keeping, we don't need the coffee anymore, we don't need the cards anymore. We're going to be using a different set of materials. So there's usually somebody at the table who's like the captain. I can see them standing up now, thank you guys. Just so we kind of know what we need and what we don't. So whilst you're doing that, I'm just going to start with this analogy that I have, which is this thing right here. I actually brought this with me. This is a Rubik's Cube. And a Rubik's Cube is a great puzzle. And it is solvable. I'm not going to do it on stage, don't worry. I wish I could. That would be so cool, huh? I'm like just talking to you guys and like, it's done. But the reason why I brought this Rubik's Cube onto stage is because I want to explain to you guys that there are processes in which you can solve this thing without being an IQ 180. We use things called algorithms to solve a Rubik's Cube. So is there anyone who can solve this thing as well? I might give it away. Anybody wants to have a shot at this right here? Okay. Can I get a volunteer to hand this down to this table? So for those of you who can't solve it without these algorithms, yeah, can you just pass this down? You got an extra challenge. Nice. Okay, so for anybody who doesn't know, that includes me. Yeah, right there. You can actually, I printed off the PDF guide. This is the PDF guide for solving a Rubik's Cube. And if you look at some of the steps, it's just basically repeating processes until you get what you need. I think I put it on my slides, actually, because it is small. There we go, yeah. So this is an algorithm. This is a process where you input certain actions and you get what you want out, which is a solved Rubik's Cube. So we also use the word algorithm a lot when we talk about social media and YouTubes and feeds. And it is a complex mathematical process that's happening in our computers, but we can also break it down into a Rubik's Cube. This is how we solve them. So Bitcoin uses algorithms. Bitcoin uses algorithms to make it a sound cryptocurrency. But what is an algorithm? If you look at the definition, an algorithm is a procedure for solving a mathematical problem in a finite number of steps that frequently involves repetition of an operation. That's where my knowledge kind of stops. I really need to delve in personally into what an operation is. I never was very good at maths at school, but like I said, you don't need to be a maths expert to use Bitcoin. We're just having a bit of fun learning about some of the basics today. So why did I choose hashing, you might ask? Why are we doing the math thing? Why are we looking at Rubik's Cubes? It was inspired by one of my friends, Stephen Black. He's a guy who does process optimization in factories, and he was looking at the most efficient way to teach Bitcoin. And he listed out all of the key subjects in Bitcoin that you need to understand to call yourself somebody who's quite adept in Bitcoin. So on the left, you have everything. It's kind of like the card game, actually. On the top, you have everything you need to understand everything on the left. So to understand a block, you need to understand, to understand the mempool, you need to know what a block is. And to understand what mining difficulty is, you also need to know what a block is. And to understand issuance, you need to know what mempool is, and all these different things. So it's basically a matrix of all of the subjects that we have in Bitcoin and which dependencies or prerequisites we have. Can you show this to everybody? Round of applause. Nice, I'm very impressed. You got to give me your secrets. Like, obviously, did you memorize the algorithms? Yeah, you memorize the algorithms? Yeah, and you repeat them till you get your desired output, right? Proof in point of how algorithms are useful. So when we put all those subjects together, these are all of the different subjects we have in Bitcoin that we can start to learn about, but some of them require understanding other ones, and it gets quite complex, what we need to know to understand what we want to know. Hashing's up there on the right. That's hashing. You can see that hashing doesn't require any prerequisites, but unlocks so much in Bitcoin. If you can understand what hashing is, you can then move into mining, transactions, addresses, all of these cool things that Bitcoin does. So that's why I wanted to pick out this one niche aspect of Bitcoin. It's technical, but I think it will really unlock a lot in your learning journey, and it will be super important in the future when you ask that simple question, and the technical answer will involve hashing somewhere. It will for sure. So I want to equip you with the knowledge of why we use hashing and why it's important. So hashing in Bitcoin ensures integrity, immutability, and security. It turns data into a fixed-length digital fingerprint that can't be reversed. That's super important. It can't be reversed. And it powers mining's proof of work. So this is how hashing is used in Bitcoin. It's a lot of big words. Don't worry about this. We're going to have a really simple activity. Now, we're really going to use those red and green tokens that you have on your tables, so make sure you've got one nearby. And in your materials box, you're going to have different wallets and envelopes. And on one of them, you're going to have a piece of paper in one of those plastic wallets that says this. I'd like the person at the table who has the box to try and find that piece of paper, and if you found it, just put it in the air. Scramble through a little bit, and you should find a piece of paper that has this text on it. If you found it, just put it in the air. Volunteers, you want to circulate and make sure people can find what they need? OK, we got one over there. Great, 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 great. We got one over there. That's fantastic. Over there, perfect. OK, people are finding them. That's good. OK. So this is a very simple sentence. It actually uses every letter in the English alphabet, which is why I chose it. Little geeky thing. But why did I choose it? It's a very small amount of information. We could call it data if we want. It's a very small amount of data with only a few words. And each table has a copy. But what I want you to do is now verify the information. I want you to go to a neighboring table, and I want you to verify, do they have the same information as you? When we transact, we need to make sure that we agree with each other, right? We need to verify the information. We need integrity and security. So let's just do this with a simple sentence. So the person who has the piece of paper, I'd like you to go and find somebody else on a different table who has the same piece of paper. And I want you to verify. Yeah, you can start now. And I want you to see, is this the same sentence? Is the spelling the same? Are the animals the same? Is the structure of the sentence the same? All right. So you've gone and verified something very easy. Face-to-face in person, Easy process. If it was the same, I want you to pick up your green token and just show me at green. If it wasn't the same, show me at red. I got a green, I got a green, I got a green, I got a green, I got a green. I got greens all over, right? Okay, excellent. So everybody agrees that the sentence on all the pieces of paper are the same. We managed to verify something. You can put the tokens down now. Awesome job. That was an easy process to verify a short sentence. I want you just to think really quickly as a table, like, how was the information verified? How did you actually verify it? Talk to your table about what you did. Tell your table how you verified the information. And then think about how you could verify this information without seeing it if you were separated. For imagine you had somebody in Australia and somebody in Switzerland and somebody in Brazil. How would you verify a very short text? I'll give you a minute to think about this, and then if I can get a volunteer with a mic to just ask some ideas. Where's my volunteer with a mic? Do we have anybody? I think Ben kidnapped it, maybe. All right, so just think in your tables really quickly. How did you verify the information? It was obviously pretty easy. You were in person. But how would you do it if you were separated, if you couldn't see the text? And how would you do it if you weren't in the same room? Imagine your husband has a copy of the same text at home. Or imagine it's one of your colleagues in New Zealand. How would you verify that they have the same information? All right, we got a microphone somewhere? Yeah, great. Is anybody wanting to just share how did you verify the information? Easy question. Just anybody want to jump on the mic and say how they did? You pick anybody out? Just raise your hand if you want to jump on. Oh, we got a hand up there, over on the left. Yeah. Thank you. Thanks very much, guys. I appreciate participation. I just want to find out. It'll help me get to where I want to go. How did you verify the information at the back there? Oh, I think we got a mic out. OK, great. Maybe just double check it's flipped on. There we go. Don't trust verify.
Okay, so you could send a text, a picture, FaceTime, those kind of things?
Yeah, exactly. We're so blessed nowadays with all of this technology we have, actually verifying something separately. That's perfect. Verifying something remotely would be super easy. It would be very easy. You just send a photo of the piece of paper, or you could text it out. And these are easy ways to verify remotely. But there's some issues with this. If we were to verify it remotely, we could send the text, but autocorrect sometimes plays a trick on us, right? You can autocorrect something, and it's misinterpreted on the other side. You're like, oh, that's not what I was trying to say. Also, there could be somebody listening to the conversation. You mentioned like FaceTime, Facebook, Gmail, whatever. Oh, speaking of Google, I realize the feedback form isn't working. You need requests for this. Thank you, Google, and their centralized processes. I should do it myself. Anyway, side note, side note, side note. So yeah, there could be somebody in the middle listening in. They could intercept the information and know exactly what you're talking about. And this could be like an authority who might be just recording what you have to say. Or it could be somebody more malicious who wants to attack you and use it as a vector of vulnerability. If you're sharing something secret, right? If you think about, I don't know, like intimate photos. If you're sending these from one person to the other person, there's maybe somebody in the middle, and you don't want to share that way. You might want to verify information and also ensure that it hasn't been tampered with. Because the person in the middle could also change the information and send it to the person as well. So you're really trusting these networks to verify information and not mess with the transmission. OK, I told you I work in threes. So that was number one. We verified that small sentence. But now if you look through your documents, you're going to have one copy of this beautiful document called the Bitcoin White Paper. Now, this is what Satoshi wrote. And Satoshi proposed how Bitcoin was going to solve the money problem. You have a copy of the white paper on your table. Now I want you to verify with another table, is it the same document? It's 9 pages. I'll give you 2 minutes. Stand up and try and verify with the other person, is this the same document? Find another table, have a quick look, try as quickly as you can to verify, is this the same white paper? You'll probably notice I make things easy, and then I'll make things hard, and then I'll get to the solution. I'm going to come down because I like being with my people down here. I feel more comfortable down here. All right, so who's verifying? We got some people verifying? Yeah, verified? So are these the same document? No?
That's Bitcoin.com. This is Bitcoin.org.
Excellent. You guys, tap on the back, tap on the back. These guys are into page number what? Which page are you at? Page number...
It's up.
Which page? Page 6 of 9. These guys are going quick.
We're doing a very cursory...
A scan read. You're just going to speed run it and see if it's the same. Is this the same document over here? Oh, we got 3 people. Great.
Yeah.
All right. By the time I'm back on stage, I'd like you to return back to your places. You don't have to verify it fully. It's just we're doing an exercise here, and I want to make sure you're feeling the pain of what it is to have to manually verify information without using this magical thing called hashing. OK, so people are back at their places. The people who verified, if you're 100% certain that you've verified that the documents are the same, show me the green token. If you're sure they were the same, green token. We got some people who are 100% sure. 100%. If you're doing this, you're not 100%. OK, the guys who didn't even attempt it and were just like, this is too impossible, show me the red. OK, we got some people who didn't try it. We got a few reds. So a lot more reds than last time, right? There are a lot. And the people who are just like, I don't know, raise your hand. The people, I have no idea. OK, so you guys probably tried to verify the document in the same way that you verified the very short sentence, right? You went to each other's table, you looked at each other's documents with your eyeballs, and you read it as quickly as possible, trying to point at things that looked kind of the same. Right? I heard a lot of, yeah, that kind of looks, yeah, I think it looks pretty good. Looks pretty good. Yep. But you're not sure, right? There was actually an error in most of the documents. The one at the top is the one that Satoshi published, www.bitcoin.org. And on the 4th line of the text, just the very 4th line, I changed something really subtle. I changed bitcoin.org to bitcoin.com. What's the difference? Bitcoin.org is the website that Satoshi and the Bitcoiners use to promote content and information about Bitcoin, whereas bitcoin.com will point you to a whole other cryptocurrency called Bitcoin Cash. These are only 3 letters that I changed, but it was on line 4 of the information. If you'd have started to really verify that information, you would have found it pretty quickly. But we're humans, and you're humans, and so am I, and I understand it. We're not going to be able to spot these very small errors. Not easily, anyway. But some people did. Raise your hand if you spotted these errors. I think there was a table at the back. Yeah, my mister over in the pink shirt actually managed to pick that up. So I'd like to give you a round of applause for being a verifying, parsing machine. That was really cool. So you guys are right about now. You were out of consensus because you didn't know for 100% if it was right or not. And even if you thought you were 100% right, chances are you were actually wrong because you didn't spot that small error. And one table did. So that was pretty cool. So in fact, if we go to the website and we go to the internet and we ask the author of the document, Satoshi, which is the right one, it's actually the one at the top. That one is in consensus. That document at the top is in consensus with Satoshi, whereas the one at the bottom is out of consensus. And this is the problem. How do we verify information to be in consensus? Your final document right now is a page of gobbledygook transactions. Now, I'm not going to labor the point. I'll give you a literal minute or two to try and verify with a neighboring table if this information is the same. It's a JSON file with amounts, fees, balances, addresses, senders, and receivers. This is important information. We want to know who's sending what to what. So try and verify it right now. Take 2 minutes and try and verify these transactions. All right, you managed to get my Rubik's Cube then. Excellent. I knew somebody would do it, and it was you. Perfect. OK, so we're verifying information. Unlike the white paper, it's not information that is easily readable. It's not sentences with syntax and verbs and vocabulary that we're familiar with. It's just data. This is very abstract information. But it's arguably more important than a full sentence. To a lot of different people, we have about 25 transactions here. All right. I'll ask you guys to return back to your places because the result isn't the most important part. The part is the experience of what it's like to try and verify this information. So, you got one there? OK, can you grab a mic and can I hear from what's going on? Thanks, Ben.
You want to share your... We have someone here who has found the difference. You want to share your method?
Oh, I just honed into amounts and I started reading one by one.
OK, so you went to the amounts first?
Yeah.
Yeah? And what is the error? What did you find?
One of the transactions is 472.81, and the other one is 4720.81.
OK, so what's the difference?
A factor of 10.
A factor of 10.
Yeah.
That's exactly right.
Good job.
OK, so on the left, we can see that transaction number 12 is for an amount of $472.81, or pounds, or euros. We don't care. It's an amount that's important, 472. But if we add 1 0, just 1 0, it has a huge impact on that transaction, right? And you guys were trying to verify how many different characters, how many different amounts. It was super difficult to verify, and this is part of the problem here. It looks like, Benny, you found something.
Yeah, there's something here. What do we got? We've got amount. What is this page? Page 3, amount 3870.68 versus 387.68. This is from 2024-09-01.
OK, so what's the difference in those two amounts? Sorry, I'm not very good at
I mean, a difference of basically 3,000 and what, 500 something ish.
Yeah.
Yeah.
So we're finding other errors as well in this information. So when it comes to transactions, some of the thank you very much. Can we give these guys a round of applause as well for finding a very small and difficult to find error? So there were only 2 documents in this room. There were 2 versions of the transactions, but we've got about 12 tables with 12, maybe 15 people trying to pass through the information. And how long did it take us? And most people didn't succeed. Only 2 people really found some of the errors, and the errors were very small and hard to detect, but super important. Can you imagine logging into your bank account and seeing a 0 missing? Now, can you imagine logging into your bank account and seeing an extra 0? This is the difference that it means when we're verifying information, and when we talk about money and transactions, it's crucial. And that's where hashing comes in. This is what hashing looks like. You don't need to know this. I don't know this. This is also what hashing looks like in the blockchain. And you don't need to know this. And I do understand this, thankfully. This is where I'm at right now. Like I said, these are operators. It's a mathematical process. It's just like solving that Rubik's Cube, except it's non-reversible because of this mathematical function that we use. And why do we do all of this? For lots of different reasons. But one of the most important reasons is that Bitcoin uses hashing to verify information. And we can verify this together using the same algorithm. If you guys want to scan this QR code, we'll jump into a website. Hopefully this QR code works. And this website is run by a guy called andersbrownsworth.com/blockchain/hash. And it'll take you to a little website where you can actually push information through an algorithm called SHA-256. SHA-256. It's this one we just looked at here. This is SHA-256. And here's how you can do it. It's super simple. Like I said, you don't need to be a mathematical expert to use Bitcoin. You just need to have the tools and know how to use them. So this website is a tool that we can use to verify information. So you can actually type into the field here, the quick brown fox jumps over the lazy dog. You can hash that information. It becomes your input. And then it's going to give you something magical, which is the output. At the top, we have the sentence that everybody had. That's what you had. The quick brown fox jumps over the lazy dog. And when we push this into an algorithm, it does all of that complicated maths in a one-way process, but it spits out a fixed length of characters, letters, and numbers that should all be the same. If everybody types in exactly that sentence, you should be able to get that. Is there anybody who's tried this out and it works? Is there anybody hashing right now? Yeah, we got Emma at the back, I think. Some people, raise your hands if you've got this exact hash. All right? Excellent. OK. So if you've got this exact hash, it means our information is the same. What I input is the same as what you input. But it's also going to be super useful to see that how, when we change it, and I encourage you to do this, change the information, change the word dog to cat. It's like changing a 0 to another 0. You'll see that when we move from the quick brown fox jumps over the lazy dog to the lazy cat, the hash has radically changed. So radically that we can immediately see that this is not the same result. We can also change cat to rat, and it does the same again. It changes so much that we can very quickly see that the hash on 1, 2, 3 sentences is totally different. We can also hash larger things. So the white paper that we were reading with the difference between the .com and the .org, you remember we were verifying this. But instead of reading 9 pages quickly, I could just copy and paste it into the algorithm, and I would get this hash. So if you did the same thing in Australia or in New Zealand, and you were to copy and paste it, and send me this hash remotely and blindly, we could see if we have the same information. And this is the power of hashing. Bitcoin uses this to verify transactions. We looked at the 0 that was missing and the 0 that was added, and we said, that's no good. But instead of reading through all this information and trusting ourselves to not miss the mistakes, we push it through an algorithm and get the hash. 25 transactions reduced into a very small string of characters, letters, and numbers. And if you have the same characters, letters, and numbers as myself, well, that means that the information is the same. And that's the power of hashing. This is how we can use computers to verify our transactions and data. And it's all about this. Are you in consensus? Or are you in conflict? Do you agree or disagree? It's very binary. Computers work on ones and zeros. It's either yes or no. And we're using hashing to be able to process information to tell us, is it the same or different? This is where it gets really interesting, though, because we're going to delve into blockchain, which essentially is the stringing along of a series of hashes. Transactions built upon transactions, built upon transactions. And all of them have been verified. This is the power of blockchain. It's a chain of blocks. In those blocks are transactions, and those transactions have been hashed. So let's look at it this way. I take my data, which is my input on the left-hand side here, and I push it through the algorithm, the famous SHA-256 algorithm. And it'll give me a hash, which is very easy to verify. It's almost like verifying a color of a bead. What do I mean by that? When you condense something very complex into something very simple, instead of reading every single page of transactions here, I can just be like, orange? Yep. Blue? Yep. Purple? Yep. Orange? Yep. And hash. Black. Yep. Very simple way to run through. If the colors are right, that means the hash is right. And if the hash is right, it's because the input was right. So the information going in is being condensed into something easy to verify. Now, this is where you guys are going to try and use a blockchain to verify some information. On your tables, you'll have a Ziploc with elastic bands and beads on them. I'd like you to hand them out to everybody at the table. Find the Ziploc with the elastic bands and the beads. And make sure everybody has one. All right, this is your blockchain. These elastic bands and the beads on them form a blockchain. Each bead is a hash. So imagine it almost like this. Imagine each bead represents a large amount of transactions that you can't verify as a human, but they've been hashed for you into something very simple, which is a color. I want you to check now at your table, do you have the same sequence of colors on your blockchain? I would suggest starting with the orange bead. Start with the orange and work out if they're the same. Let's try and find consensus with something simple, colors of beads. I'll give you 3 or 4 minutes. I'm going to come down and help. Let's see if we can find if this matches. Hey, my Okay, so if you have the same sequence of beads as other people on your table, I'd like you to turn your token over to green. If it's the same, move it to green. If you're different, move it to red. You're out of consensus. Perfect. So now I can really quickly see who's in consensus. Very quickly, I can just verify. You guys have the same information. You have different, you have different, you have different, you have the same, same, same.
Some of them same, but some of
Half a
them
different. So you have orange, green, blue, pink. Exactly. So you guys are the same, but different to you. Okay.
three. We have 5 people same.
Okay. So what I'd suggest you guys do is start by saying orange. Who has orange? Okay. Who has green? Who has blue? Okay, so if you don't, turn over to red. Who has pink? And who has yellow? Okay, so 1, 2, 3, 4 of you, 5 of you all have the same. So you guys are a majority on this table, right? And the other 3 people at the table have different. Excellent. Thanks. That's where I want you guys to be. 3 and 3 here? That makes sense. I planned for 8. There's 3 that are wrong and 3 that are right. So find out, you guys should have 3 people who all have the same beads. So you agree with each other. Hey, Steve. So I'd like you to turn those over to green, because you have consensus between each other, whereas you guys all have different. You're unique, right? When it comes
Pablo,
to transactions, being unique is not a good thing.
Pablo,
Yes.
I've got really bad news.
Yeah.
I'm legitimately colorblind.
Legit.
Yeah.
Wow. Okay.
I don't even know if I'm in consensus. So, does this mean that I'm not running a node? I need to trust somebody else to do it for me?
Yeah, you need to cloud server it and trust somebody else's node. That's it. We're learning Ben BTC sessions as well. Thank you for this. This is good feedback, actually. I didn't think about this aspect. I used to work in summer camps as well, and like we'd always hand out like bibs and vests to kids, be like, your yellow team, your blue team, your yellow team, and the kid just playing for all the teams. I was like, I think we need to speak with your parents. It's happened a few
I didn't
times.
figure it out until too late.
Okay, so at the table, you should have, let's have a look. You should have maybe 3, maybe 4, maximum 5 people who all have the same sequence of beads. And then there'll be 3 other sets of beads on the table which are different from the others. All right? So there'll be a majority who agree with each other, depending on if you're 8 at the table. And then there'll be people who don't have the same sequence, some people who are out of consensus. If you're out of consensus, I'd like you to take off the beads that don't match. And in the box, try and find the beads that everybody else has. And I'd like you to build up your blockchain to become in sync with the other people. So you'll actually have some spare beads right there. And you can use these spare beads in the little box to modify your blockchain. Make sure that everybody at the table has the same sequence of beads. Each one represents a block. And the elastic band represents the chain of blocks, the sequence. So orange, green, blue, pink, yellow. If you flip this around here this way. Orange, green, blue, pink, yellow. Also you. Orange, green, blue, pink, yellow. You guys are all in consensus.
But they're different.
And you guys are different. So I'd like you guys to try and match this sequence here. Orange, green, blue, pink, yellow. You've got a green token, that's perfect. You can copy from him, because now you know that if he has what he has, you copy him and it'll all work out, right?
So you're saying that, okay, so originally us 4
Yep.
had the same sequence, and they had different sequences
Yeah.
compared to ours. it was irreversible.
The hashing process is irreversible. So you can't go from a yellow bead back to the transactions.
Oh, I see. Okay.
You can go from the transactions to the color yellow in this analogy every time.
So you can rearrange the order of the blocks.
You can't organize the order of the blocks because also they put the time in the hash. That's something a bit complicated. I'm going to say we don't get into that in this workshop because there's actually like a date built into each block as well. So you can't reorganize the order.
So then why were they allowed to reorganize?
Because they're just going back and rebuilding to be in consensus with you. But for example, I can't take that out and reorder them that way around and be like, that's the thing, because it doesn't match with her and it doesn't match with her. So you're out of sync as well now, right? It's a network effect of everybody agreeing with everybody. And if you do something to mess it up, you're the one who's out of the network. So you have to join back in. And this is how Bitcoin works, is that essentially you want to participate in the marketplace, just like the card game, right? You want to be holding cards, not like Pokemon cards. So you actually join the consensus,
Right. Yep,
and then you can build on it together.
So I got that part. I got the idea that we're in consensus.
Mm-hmm.
And they weren't. So they had to go, you said they had to go back in time?
That's right. Yeah. We can get into it as well.
Yeah.
Okay, so hopefully by this point you guys have all matched up your beads so they're in consensus. Can I just have a look at the green tokens? If you're green, it means you all match. Green, 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 green. Green, 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 green. Everywhere is green. So all of the tables are in consensus. This is great. Okay, so this is what the conference center looks like right now, more or less. It's not the same colors. We've got orange and blues and purples, but essentially the conference center looks like this thing on the screen. We have tables where you have sets of beads, and all of your beads are the same sequence, so you're all green. You're all in consensus on your table. Each table agrees with each other. But I'd like everybody to turn over their token to red. Everybody turn over your token to red. If everybody turns it over to red, we can start the next activity, which looks like this. I would now like you to go to the nearest table. So for example, you two are the nearest tables to each other. You two are the nearest tables to each other. You two are the nearest tables to each other right here, and so forth. Go to the nearest table and check the other table's sequence. If it's the same, go back to your table and turn over to green. I want to show how we can make a network of consensus. Verify with your neighbors, do you have the same? And if you do, turn it to green. So you're good? Flip it over. You guys verifying? Excellent. Okay. So people checked with their neighbors and then went back to their table, and you checked with your partners at the table, and they checked with their neighbors. So what this means is we've essentially made a network that is slowly confirming with itself. If we look at the diagram up here, you didn't know if your neighbor was in consensus with you, so you reached out. And as a partnership, you reached consensus. And then you were able to come back to your table and check with some of the people at your table. And as I saw the room go through the process of verifying information, we eventually built out a network where across this conference center, we've now reached consensus, right? And this is what Bitcoin does. Normal systems, like my Google form that's not working, works on a centralized system. I depend on Google to verify my information. And decentralized networks work by having very key players that are super important to the maintenance of the network. But actually what we've made here at Learning Bitcoin today, with a very simple example of beads representing transactions, is we've made a distributed network. And this is how Bitcoin works. This is the network of Bitcoin. Each one of you has a copy of a particular string of hashes. And the hashes represent information, which is too long to verify humanly. So we've hashed complex information and strung it together. And once we've strung it together into our sequence of beads, we've compared that with our neighbors and worked out that they also have the same sequence. And that's what each little bee on this network represents. We call these things nodes. This is what a node is. And you can run one in your own home, and you can be your own bank. When people say be your own bank, that's kind of what you're doing. You're verifying information and your transactions, not just of yourself, but of everybody who uses the network. You can verify transactions, and the easiest way to verify them is to take a copy of them and hash them. And if that hash is the same as the hash of your neighbor or the hash of the person on the other table, well, guess what? You guys all agree with each other. And this is why Bitcoin uses hashing, or at least one of the reasons, is that we can find consensus on complex information. And when that information is transactions, we need to agree. Because if we don't agree on transactions, problems ensue. But if we can all agree using a simple process, we have harmony and balance and consensus. So I want you guys, everybody, to raise your right hand. And I want to put it over your shoulder. Give yourself a tap on the back. You just became a Bitcoin node. Nice job. That's the end of workshop 2. Now, we don't go all the way into mining and layer 2s and Merkle trees and timestamps. It's more complicated than what we've done today. But I'd like you to understand that hashing has a value in Bitcoin which permeates all aspects of addresses, wallets, transactions, and mining. All of these things you'll hear about tomorrow on stage. Every single process is using somewhere along the line a hash. And when I want you to think about that, I want you to think about how hard it was to verify information as a human and how quick it can be to verify information using a computer. And that's why we use cryptocurrencies. And that's why we particularly use Bitcoin, because it's the biggest network. And that's what we've created today. I know this feedback form isn't working. I'm going to try and pull it together after lunch, but that's the end of workshop 2, hashing, nodes, and mining. If anybody does want to delve into a bit more mining stuff, tomorrow I'm going to also do another workshop on a smaller table. And if you want to come and find me, we can do a mining activity where I show you the final piece in this puzzle, which is how miners are hashing again and again and again and again to get the magic answer they want. We can do this with dice tomorrow, so we'll bring some more beads along and we'll have some fun. So if you do want to do the final piece in the puzzle, come find me tomorrow. We got lunch next. It's 12:30. We're right on time. I'm going to take a 30-minute lunch break. After this, we're going to come back and we're going to look at fees, speeds, and layer 2 on the Bitcoin network. When you send using this network, there are fees. I'm going to explain to you how the fees work. I can see material people packing up all this stuff on their table. It might be a good time to collaborate everything together and put things back into your baskets. I wish you a great lunch break, and I'll see you back here at 1 p.m. where we'll do workshop 3. Thank you, guys.